Today we're going to discuss implicit differentiation. So let's begin. Implicit differentiation. So sometimes a function is defined explicitly. For example, if we define y equals 3x squared minus 5, this is an explicit form of definition of a function. If we say xy equals 1, or x squared plus y squared equals 4, or x cubed plus y cubed minus y equals y squared, these are all implicit forms. We can still differentiate given an implicit form, hence the term implicit differentiation. So the main technique we're going to use is the chain rule when we do this. So let's take a look at an example here. Find dy dx given that y cubed plus y squared minus 5y plus x squared, let's say minus x squared, equals negative 4. The strategy here is to differentiate both sides with respect to x. So what's going to happen here? We're going to get separate terms to differentiate using the addition rule. On the right, we're simply going to get 0 because the derivative of constant is 0. And now, here's where we're going to use the chain rule. We see that y cubed, to differentiate that, we need to write 3y squared times the derivative of the inside, which is this y. So we're going to add on a dy dx. Similarly, here it's going to be 2y times dy dx. Here it's going to be minus 5 dy dx minus 2x equals 0. So we're going to get dy dx 3y squared plus 2y minus 5 equals 2x. And then we're going to get dy dx equals 2x over 3y squared plus 2y minus 5. And that is going to be the derivative of this function, which was defined implicitly. Let's look at another example where we determine the slope of the tangent line. So let's look at determine the slope of the tangent line to the graph of, let's say, x squared plus 9y squared equals 9. At the point let's say 0, 1. we see that 0, 1 is a point on this graph. So let's begin by differentiating both sides with respect to x. Very nice. This becomes 2x plus 2 times 9 times y times dy dx equals 0, which in turn becomes dy dx equals minus 2x over 18y, which is minus x over 9y. So we have dy dx is minus x over 9y. And then to find the derivative at the point xy, let's say at x equals 0, y equals 1, we're simply going to substitute 0 for x and 1 for y. It's going to be minus 0 over 9 times 1, which is just going to be 0. Thus, the slope of the tangent line to x squared plus 9y squared equals 9 at the point 0, 1 is 0. And the equation of this tangent line will be y minus 1 equals the slope times x minus 0. Which can just be written y equals 1. This makes sense because derivative is 0 indicates a horizontal tangent line. The derivative being 0 indicates horizontal tangent line.